Hi, welcome to the next episode of AI Guide to the Galaxy. My name is Oleg. I work with Docker's DevRel team, and this is my honor to welcome our guest today. He's one of the newest members on the Docker Model Runner team, and we're going to talk about the recent improvements, what is happening with the project, what new functionality is there, and what you can achieve and do with Docker Model Runner and hosting and running your language models locally. Please welcome Eric. How are you doing today?
I'm doing good. Thanks for having me on.
Awesome. So you joined Docker Model Runner team just recently. Uh, maybe can you maybe share a little bit of your path and how do you end up on the team?
Sure. I think I joined Docker about 7 weeks ago. Not sure exactly the dates, but how I ended up here, I guess I've been an open source developer for quite a while. And about a year or two ago, I started. I've quite a varied background in open source, but about a year or two ago, I started working with AI more because with ChatGPT and all of these things, the technology grew rapidly, and I want to learn more about it. So, and then I started looking at technologies like Llama CPP, which is like the core inferencing engine for Docker Model Runner now, and yeah, just kept on learning more and more about open source AI technologies and how we can use containers to encapsulate those.
Awesome. So when you're joining Docker, you were specifically joining the Docker Model Runner team to push this project forward.
Um, yeah, specifically at the start, even though yeah, I like working on other projects as well, but yeah, it's my focus.
No, that is awesome. And you've been also like an avid contributor to Docker blog. I've seen a number of articles written by you. So it's awesome to have you with the team. And I think we're very, very happy to have you with us. So let's talk about Docker Model Runner. So we had the previous episode with Jacob where we sort of looked at the motivation for the project, how it came to be, a little bit on the architecture, like what it can do, what it cannot do, how it wraps around Llama CPP as the engine, but also there are other parts because you need to load the models, you need to have the load balancer, you need to actually provide and like fetch the models to give this Docker-like experience, right? Because the whole idea was to give people the possibility of running models with the same ease as they run containers. So, and that was a few weeks back. So now there are a number of features which have been shipped, and also a number of things that are in flight right now. Very interesting additions. So let's quickly go through those. One of my favorite ones, and since we're talking about wrapping Llama CPP, is of course the possibility of Docker Model Runner, possibility of using other inference engines under the hood, right? The whole architecture was made engine agnostic. So can you maybe share what's happening, what are we working on, and whether this additional complexity that was built into the project from the start, is it paying off or was it like a mistake?
It's certainly paying off. When Docker Model Runner was initially released, it was released with Llama CPP as the core inferencing engine, keeping in mind that we may want to expand out to support other inferencing engines. We also released with accelerated AI inferencing for Metal and CUDA, which is basically tied to Apple and NVIDIA. So we also kept in mind to be extendable from the hardware perspective as well as the software perspective. And in both those areas, we're currently expanding off. We've been working with NVIDIA to add support for something called NVIDIA NIMs, which are like a containerized inferencing engine and model container images. And we've also been working on something called vLLM, which is another inferencing engine. It tends to be used on the more powerful GPUs, like the expensive ones that many users tend to use at once. And in terms of the hardware support, we're expanding out there as well. We're adding things like ROCm for AMD. That's in progress, but what we have actually delivered is a framework called Vulcan, and Vulcan is an open source generic kind of GPU driver that works on any GPU, which is actually super useful because it means now you can run an AMD, integrated graphics if you don't have a dedicated GPU at all, or even like the more kind of bespoke platforms like ARM SoCs and this kind of thing.
That is awesome. So let's go through those in order. So you mentioned vLLM, right? And this is super exciting. vLLM is the like one of the highest throughput, like efficient, production oriented engine for serving LLMs, and I think this is very, very awesome. How does it work under the hood? Do people run the same models using Llama CPP or vLLM? What's our vision there? Do we kind of fork it, or do we use the same upstream versions builds?
These are all good questions. We don't really fork, like we're trying to take an upstream first attitude to everything. So any contributions we need, we always try and push to places like Llama CPP or vLLM. Under the hood, how they work, that's a good question. From the user's perspective, they're both, we speak to both inferencing engines via what's become the de facto standard now, basically, which is the OpenAI compatible API. So from the user perspective, the experience is almost identical. You don't notice much difference. But there are some differences under the hood. Models is one. They have two different model formats. Both are very popular. These are basically the two most popular around right now. So Llama CPP uses GGUF. I can't remember what that stands for. But anyway, it's unified format. I forget the GG because that has kind of two meanings. It's the initials of the creator, but it also has another meaning in this context, and I always forget.
I think it stands for generic GPT unified format or something like this.
True. Also, the creator of that format is Georgy Gurganov. Is that how you pronounce his name?
I will not embarrass myself saying that. Georgie.
Yeah.
He's famous enough to go by the first name. So yeah, it's a.
Georgie's a great guy. I think it's deliberately his initials also, but
Right. Okay. So Llama CPP uses GGUF, and this is the sort of the custom format, which, from my experience, was running models using, well, Docker Model Runner. Usually GGUF models are quantized from sort of floating point weights that are used during training, and then they're quantized into either shorter floating point weights or into the integers, and then that is packaged, and that's to like sort of a layman like me, that's the core of GGUF. What's the vLLM? Is it, if it's not using GGUF, what's the deal there?
Yeah, so vLLM use safe tensors files. It's slightly different. GGUF tends to do everything in one file, except in the case of multimodal, there's a slight difference. But generally, safe tensors tend to be scattered among many files, and tend to be, this isn't always true, but tend to be tuned more for like the crazy NVIDIA H100s that like cost 30,000 euros or whatever, so, or dollars.
Right. Okay. So, but that expands majorly the amount of models that you can run via Docker Model Runner, because like half of Hugging Face models are just providing safe tensors, right? So now, if vLLM becomes a viable option in Docker Model Runner, I can just get those and run, and I don't need to wait for the community to provide GGUFs or learning how to convert them myself?
Exactly. The two formats at the moment are practically a duopoly at the moment. So it's great to be able to be bringing support for both of those. Maybe as time moves on, there will be other competing file format standards, but those are kind of the main two now. But just to expand this point further, how Docker Model Runner uses these actually puts it in an OCI artifact format. And we actually think that's quite useful because now you don't necessarily have to push and pull from Hugging Face or other AI specific repositories. You can push and pull to any OCI registry. So that's like Docker Hub, Quay.io, GHCR, or you might have private in-house OCI registries, which is
Yes, everyone has those. Like any normal company would have.
factory, all these.
Yeah, awesome. No, this is great. I like the OCI format that we are not losing that. I think this is a very good addition to the ecosystem. I understand that Hugging Face is sort of the de facto standard for model distribution, but it also feels a little bit awkward because those are just Git repositories. And I don't know why, but like it feels like immutable artifacts are like a better approach. I don't have the technical explanation why myself, but
There are some advantages of OCI. They're everywhere. That's always the main one for me. They're everywhere. Everybody's got them, the infrastructure spun up for it already. There's also things like a lot of the OCI registries, they have like scanning tools to scan for CVs and this kind of thing. And that's super useful, especially with models, because models are often this binary and God knows what's in that binary. Like what kind of knowledge is in there, if it's biased or not. So you do really want to be scanning those moving forward, because we see things like agents now where it's kind of like, and people talk about YOLO mode. It's like, go computer, do whatever you want with this AI model, and that's kind of scary. So I think scanning your models is important. The other thing I want to say is that we're not trying to force people to pull from a certain place either. Like you can pull from Hugging Face with Docker Model Runner, and that works great as well. I do that all the time. It's very useful.
This is interesting. If I have a model on Hugging Face and it contains both safe tensors and GGUF, and I do Docker model pool and say just the model name, will I get the GGUF by default or will I get safe tensors? We're gonna leave that as an exercise for the viewer. Try that and leave a comment below, because
yeah. One thing I worry about talking about vLLM and safe tensor is it's not even in our main branch yet, so it's coming. But
it's by the time the video is out, I'm sure it's out and you can try it right now. So I like this very much. It expands the amount of engines that we can run. It expands your options. If you run vLLM in production, you might want to use the same models and the same engine also in your development environments. So I think this is a great addition and it expands the functionality quite well. You also mentioned Vulkan. So we expanding the amount of hardware where we can run. Can you show me? Do you have a non Mac Silicon environment?
So I'm clearly on a MacBook, as you can tell by the UI. But I have a machine in my house. It's a fairly big. It's like a small mini PC, and it has an AMD CPU, and it actually has no graphics card. I just use it for basic AMD building for the AMD platform. But every modern CPU today has integrated graphics. So up until now, we couldn't utilize this. What's super useful about Vulkan is basically Vulkan is like the open generic standard for GPUs, and that's really small GPUs and super powerful GPUs. So in this case, I'm demoing on integrated graphics. So you'll see AMD Radeon graphics. That's an integrated GPU. But it could also be a dedicated AMD GPU. It could be an NVIDIA GPU. It's a generic framework. It could be an ARM SoC. So this is a new feature of Docker Model Runner, because in the past, on this hardware, on hardware like this, we couldn't utilize the GPU for accelerated AI inferencing. And now we can. So on the right is my GPU graph. You see it's not being utilized at all. It's at 0%. And on the left, I'm going to write Docker Model Runner. This model CLI, it's like a development binary of Docker Model Runner. This is the equivalent of typing Docker Model Run. It's the same thing. So, of course, I forgot to specify my model. So I'm going to run Llama 3, and this is actually, I'll say, tell me about AI. Write an essay. Tell me about. I clicked enter, so it already started going. But as you can see, it's writing an essay on the left, and on the right, you can see it's utilizing the GPU at 97%. So that's so cool now.
That's awesome. It goes pretty fast as well. Like, that's not a powerful card at all.
Yeah, no, this is a cheapo CPU. So yeah, it's pretty good considering. Yeah, the CPU is probably worth like €100 or something.
No, this is awesome. This is this is great. So if I have a random old machine somewhere in my house, I can probably use that as a server for Docker Model Runner now, which is quite good. And then it expands the ability to run. I think in general this is very, very good.
I think this feature alone, it probably like increased the amount of GPUs we can run on by like 10.
Yeah. I mean, like, we had NVIDIA and we had Apple Silicon and maybe some other NVIDIA setups. No, this is awesome. I also noticed, so just in case, if you're running and you have AMD cards laying around somewhere or hardware with that, try it out. Like, run a small model, make it, try to run Quen Coder of a decent size, and then see whether it actually produces outputs that you can use somewhere. I also noticed when you were showing, there was a different Docker model run experience. The UX, because before, this Docker model run was a very scaffolded, very like bare bones application, just so you can run it. You can maybe ask it the question to check whether it works or not. Now it was different. Can you share a little bit about that and why we poured efforts into this?
When Docker Model Runner was first released, we got it up and running very quickly. So the Docker Model Run experiences were very basic. It was like, give us the string, press enter. It didn't recognize various keys like up, down, left, right, or home, end, all these kind of things. So now we have kind of like, it's what I call a read line like experience. So you can go through like the history of the command you wrote. You can do home and end. Another feature we added that's kind of cool, I think it's quite useful. Sometimes you have a certain model and it kind of starts to hallucinate or starts ranting. So sometimes you can even do things like this. And the model starts speaking. But you might get sick of waiting around and have enough data. You can cancel it with Control C. But notice how it didn't leave the prompt completely. This is quite useful because you might want to keep your conversation history, so the kind of chatbot remembers the context of the conversation, even though you you shut it up basically.
I like very much how it canceled the actual request as well, and the GPU spiked down. Because in the past, I don't know, maybe those were the bugs in the implementation, but in the past it was like sometimes I would run something and I would cancel and I would kill the chat application. Not Docker Model Runner, maybe via different chat applications, and my GPU would still be going. Um, so I like that we improved this, and I like that I set the commands, um, and even the file inclusion. That is awesome. So we can provide instructions.
Let's do a quick demo on the file inclusion because that's kind of cool. But this is how you access the help menu actually, and this is worth reading if you want to learn tips and tricks. So I don't know. There's a README file here. It speaks about Docker model CLI. So I'm gonna say, read this file and tell me what it's all about at readme.md. I don't know if this code is even merged for this feature, so it'll be interesting to see too.
It's fine. It's fine. We're gonna take a little bit of time to process this video, and
Yeah, so if you look, I didn't tell it what the file's about, but I said read this file and tell me what it's all about at readme. This file describes the Docker model CLI or command line tool.
right. Awesome. What kind of files can I add this way? Is it text files only?
So I haven't experimented with all kinds of files, but it works with plain text files for sure. It also works with images. So if you're running a multimodal model, you can say, tell me what's in this picture at, I don't know, at applepie.png. This looks like an apple pie or apple tart popular in XYZ. So it actually recognizes images also, which is quite cool.
Oh, that is very cool. I saw a demo of that. I can actually try it. I think it will work on my machine. Let me try doing that. So this is an application that sits literally in the model runner demos, multimodal demo. And it's a single HTML page, which is like super, super cool. Courtesy of Ignacy. So, and it runs, and if I allow my camera, it looks at me. It works with the particular model. It connects to my local host. There are some models that have visual adapters or not. So this is that the demo recommends, and I can just do it. Look. So every half a second, it tells me what it sees. And it's very, very quick because it's a small model. Look, check this out.
While you're getting that there, I just want to say this was built upon the work of Llama CPP, which we're very lucky to have. And the first person who did this demo was a Hugging Face engineer by the name of Sun. But we enhanced it a bit further, the drop-down box, etc. So
Yeah. No, I saw this about using web GPU and like models that you can download in the browser, but it is very, very cool that we have an example where
that was great, actually.
where you can actually have the models from Docker Model Runner, and you just connect, and then it works, and it works surprisingly well. This is kind of awesome. So I of course cannot take any credit for this because it's the engineers on the team who adapted this demo, and the original, as you said, were from elsewhere.
I also think this demo is a good example of why AI at the edge is going to become more important, because in these examples, the model is viewing like a video stream. So like you probably don't want to go back to a central data center like in California or wherever that might be, traveling thousands of miles, because the latency will catch you there. Um, because it's physically a long distance. Like if you want that real time performance, think of something like a security camera that you want to recognize objects. you really want to be talking to AI inferencing loads on the edge, like maybe even in the security camera context within the same building. So imagine a DJX Spark or something like that.
Yeah.
In a
No, it is awesome. And it also, so for a long time, I was I didn't know that we can do multimodal. I only thought that Docker Mongo Runner can run language models that are text only, and that we are doing the completion API, and then there are no models that can do audio or video, or not video, images, right? And this demo opens the world of possibilities. I can now maybe do something very, very cool, and it all runs locally, which is great. And I think for me, it's also very important that it runs within the context of Docker, so I can expect to be able to run containers. So I can create complex environments and have maybe finally my local model can solve my captures, or parse my receipts, so I don't need to do expenses manually. The possibilities are endless. Granite models, I saw recently, Dockling models by IBM were allegedly very, very good at text parsing, and they were small enough. So I would try that next, and I hope that it works. And if any one of you watching will try that, tell me whether it works or not. No, this is awesome. Multimodal things, absolutely enjoyable. Multimodal things. So you said we take this, and this is the sort of the contribution. This was a demo by somebody else from Hugging Face, and we of course didn't implement the multimodal support in Llama CPP. I mean, we could maybe, no, we could maybe we have the expertise and capabilities, but we are standing on the shoulders of giants. This is both Llama CPP and vLLM, absolutely amazing projects, massive contributions from the community, from different companies, and we are just packaging the user experience there, but in a nice way. So, do we contribute stuff back? Are we trying to be a good open source citizen?
Yeah, so we're kind of growing our community in multiple ways by contributing to other projects like Llama CPP or vLLM. There's probably others, but off the top of my head, they're the two main ones. We're also trying to grow our community in Docker Model Runner to make it easier for people to contribute there. So one of the things we did before Docker Model Runner was split across 5 different repos. So now we kind of consolidated it all into one. So you just got to look there for everything. There's Slack channels, there's README, documentation, all sort of tests. And that's going well, actually. Another kind of containerized inferencing engine we're working on is something called NVIDIA NIMs. And actually that's been quite good because NVIDIA people are now contributing to Docker Model Runner to make the experience with names, Docker Compose, Docker, and Docker Model Runner all nicely integrated together for the user, basically, because it creates a good UX for the user, and it was a match made in heaven anyway, because NVIDIA names are all Docker container based anyway, so it made sense to integrate those more tightly.
Yeah, that's very, very good, because also it expands their ability to run models and run setups in different environments, because on Macs you cannot get GPU to containers, so it's unlikely that you can run even moderately small models in containers with any degree of performance.
And even then, we also have a solution called Docker Offload. So there are some AI engines and frameworks. vLLM and NIMs are two good examples where it can be hard to get stuff done without NVIDIA hardware. I find Docker Offload is super useful because you can just go Docker Offload start and then run all this stuff like you would on an NVIDIA machine. and it uses an NVIDIA GPU in the cloud, and but it gives the kind of local workflow experience.
Oh yeah, I read an article recently from Ignacy, who is also on the Docker Model Runner team, about fine-tuning some small local models using Docker Offload. So that's nice. I have to try that myself. But it was very, very interesting. He showed how you can run and train, I think he did Gemma 3N maybe. And then the task was there to mask private, private identifiable information, right? To mask the text that you give it and redact it to remove the names and places and dates and stuff like that, which you would think it's a small thing, but because your ChatGPT can do that on the fly. But ChatGPT runs on very, very powerful hardware, and smaller models do not necessarily share the same performance baseline with state-of-the-art cloud models. So fine-tuning models, I think personally, is a very, very exciting direction where the world can be going. Task-specific, small solutions running locally on the edge using like more or less stock hardware. Maybe some, yeah, you don't need to buy Bitcoin miners to run your LLM, or you
No,
don't need to.
that's a great example. You might just need access to an expensive GPU for literally minutes to train something. And then you might want to actually run that model on a weaker piece of hardware, like I just showed, running some Vulkan and an integrated graphics GPU. So it's perfect for that kind of thing.
Yeah, and then you show it videos from your pictures from your video camera, and it will identify all the intruders, and it will ask you questions like whether this grizzly bear that is ravaging through your backyard, is that your pet, or do you need to call police? Right. Thank you very much. This was a wonderful episode. I learned so much. We talked about how Docker Model Runner uses its engine agnostic infrastructure to include more engines. So now vLLM is coming or available very, very soon. And you can run more models from Hugging Face directly or package them in OCI artifacts still. We talked about AMD and Vulcan support, so you can run Docker Model Runner on a much larger fleet of hardware, which is always an excellent addition. And we did cover some improvements in user experience and even some multimodal demos. Thank you very much, Eric. It was a blast talking to you. I learned some things. I hope people watching also learned some things. It was excellent. Thank you, everyone watching. Stay tuned for the next episode.